video is to demonstrate how to make the Finch move. And again, we're going to make the parallelism between making the cat sprite move as well as making the Finch move. So let's make the cat move back and forth. Let's say I want to make it move back and forth 5 times. We've done this kind of thing before, so I'll build this program relatively quickly. So I get the motion, so I'm going to move the cat forward, say 10. Let's make it 20 or 30 steps. How about 30 steps forward, and then I'd have it move 30 steps backwards. And let's see what happens when I run that. We can see the cat. It doesn't seem to be moving. That's because it happens so quickly we can't see it. So we need to have some control and have a little bit of waiting time between there to see what's going on. So here we go. We're going to run this portion of the script. Forward, backwards, and that's it. So move forward, we waited, we moved backwards. Let's say we wanted to do that 5 times. So we'll put this around with our repeat for 5 times. So there we go. Oh, it's not quite symmetric because the moving backwards is immediately followed by the moving forward. So let's put another little bit of a wait time in there for this, and let's see if this does what we want. So that's what we'd like. We're going to move back and forth, back and forth, back and forth. We're going to do that 5 times. Turns out that instead of moving the sprite, we can actually move the Finch. So let's see what happens if we move the Finch. So let's just remind ourselves, if we move the Finch, you have to usually use at least 20. It's power to the engine that on the motor in the Finch. And let's see if we move. Watch our Finch over here. See, there it is. The Finch moves. It's moving forward because both motors are getting the same amount of power. Uh-oh, it's going to go off the edge. What happened? Oh my gosh, it went off the edge, but I caught it. But that's because the wheels are still spinning. They just continue to spin until you tell them to do something else. So I need to tell it to stop, and then the wheels will stop spinning. So we can build the same exact kind of structure that we had up there. We're going to move the Finch left and right, so the left and right in this case refers to the amount of power given to each of the motors. So instead, if we want to go forward, then we want to go backwards. So let's go minus 20 and minus 20 to see what that'll do. So again, move forward. Oh, it almost immediately went backwards. That's because we didn't let it go forwards for very long. We need again to use our wait statement. So we put the wait statement in, and just by symmetry with what we had up above, we'll put another wait statement, and then we'll bring along a repeat to put around the whole thing as we did up above. We'll do it 5 times. And this should be, notice the parallel similarity between, in this case, the exact same program is going to control the sprite, but because I have a more sophisticated device available, instead of seeing a sprite move on the screen, I can watch the Finch move in the world. So let's see what happens. It's going to go back and forth 5 times. It'll move for about a second and then reverse. Sure enough, it's going forward and then backwards and then forwards and then backwards, then forwards, then backwards, forwards, and then finally we're done. Oh no, it kept going. What's going on? Because the last time we went through this sequence of steps, we were still in the mode of going backwards. We had minus 20 to each of the motors, and we did it for 1 second, and then this loop, repeat loop, was over, and we just kept going. So at the end, if I want it to stop, I'm going to bring in the Finch control, and I'm going to set both motors to 0, and that will turn the motors off. So we'll do it one last time. And just to make it more exciting, let's go for a little bit further. Let's go to, say, 40 in both cases, and then we'll do minus 40, or let's do minus 60 on the way back. But if we go faster, then we should do it for a shorter period of time. So let's do this, and you could spend some time worrying about exactly how this is going to go, but I think this will be somewhat interesting. And so you can see it was moving forwards at a slower speed and backwards at a faster speed, but because we changed the amount of time, the total distance that it went forward and backwards was about the same.